Hi guys, today we're just going to discuss a little bit about solving formulas or solving literal equations, and recall that you use a lot of formulas. Formulas generally have more than they usually have more than one variable. They always have more than one variable and sometimes multiple variables. The quadratic formula is an example of a formula that you use that's already been solved for x in terms of a, b, and c. And they're useful. A lot of times students will use them in chemistry and physics to solve and isolate for one variable and then plug every value in so that they can find some unknown that they're looking to solve for. So we're just going to do a couple of examples. It won't take very long. First example we're going to do, if you remember that we talked about type forms of linear equations. Ax plus by equals c is the standard form of a linear equation, and we're going to solve this for y so that hopefully you'll have a better understanding of like how you could use standard form to identify the slope and the y-intercept. So the first thing we're going to do is we're going to subtract ax. We're going to subtract ax from both sides, and we're going to get by equals negative ax plus c. You could also write that as c minus ax. So formulas can be rearranged and written in different ways. I'm going to write it in this way in particular so that you could hopefully understand where the slope and y-intercept come from in standard form. And then we're going to divide everything by b, and we're going to end up with y equals negative a over b x plus c over b. And the reason really why I started with this one is so that if you ever have a line that's given in standard form, you can identify the slope of a line in standard form by finding the value of opposite a over b, and you can identify the y-intercept in standard form by finding the value of c over b. So that's just one useful way that you can use a formula to apply and find something else in a particular form. And then you've gotten that equation in slope-intercept form, and that's why that's the value of the slope, and the value of the y-intercept is b, c over b. All right, so the next one, obviously you're well acquainted with this particular formula. You know this as the Pythagorean Theorem. We're going to solve it for a. So we want to isolate a. So you're essentially, you think about the way that you perform order of operations. When you're solving an equation, you're kind of going in the opposite order of operations frequently. But we think about what's on the same side as a that we're going to have to get rid of. And the very first thing we're going to have to do is we're going to have to subtract b squared. So we're going to subtract b squared from both sides, and we're going to get a squared equals, and I'll just go ahead and express it as c squared minus b squared right now. And then we're going to take the square root. We're solving for a. We don't want to know what a squared is. We want to know what a is. So we're going to take the square root of both sides. Be careful that you don't separate the radical on the right side. It's not separately. You can't take the square root of c squared and b squared separately. It has to stay under one radical. And then we end up with a equals the square root of c squared minus b squared. And you've completely solved that equation for a. We'll just do a couple more. I think that most of the ones in your homework assignment are going to be very basic. So the next one should look very familiar. You had a unit already on area of polygons, and this one is the formula, if you recall, for area of a trapezoid. We're going to solve this one for h. So we're going to see, okay, well, if we had the area and maybe we had the length of both of the bases, then how could we find the height? So the first thing that I'm going to do is, again, we don't like dealing with fractions frequently. I know students don't like that very much, so I'm just going to multiply both sides by 2 to cancel out that fraction. So now I have 2a equals h times b sub 1 plus b sub 2. And now we think about the operation between h and b sub 1 plus b sub 2. You don't have to move them independently, and you don't need to distribute the h. The h is already separated from b sub 1 and b sub 2, so the last thing we're going to do is just divide by b sub 1 plus b sub 2 so that we can cancel it on the right side. We're going to divide by b1 plus b2 on both sides, and your final answer should look like 2a over b sub 1 plus b sub 2. is equal to the value of h, and that would give you the height from that way. So that's another thing that we can solve for. Pretty basic. Last one that we're going to do, I know this was a very short lesson, but it doesn't need to be complicated. You just need to make sure you're always thinking about the operations. So this last one, the only thing that makes this one slightly more challenging, and obviously this doesn't look like any formula we've done because I just made up some variables and numbers to throw in there just to try to see what we could do with solving for x separate from anything else. Notice that in this case, please notice there's an x term over here and an x term on the right side of the equation. You're going to have to get those x terms on the same side and everything else on the other side. So remember, our goal is to get x all by itself. So we're going to first try to get the x terms on the same side. So what we're going to do is we're going to subtract the 5a from both sides, but we're also going to go ahead and subtract the zx from both sides so that we can move it around. And what we're going to end up with is something that looks like this. Mx minus zx equals negative 5a minus c to the third. And it's okay. The order is irrelevant. You could have negative c to the third minus 5a. That would be perfectly okay. So now I've got my x terms on the same side. Last thing I'm going to do is I need to get the x separate from the m and the z. So think about that x as the greatest common factor. So we're going to take the x out. And if we factor the x out, we would be left with m minus z equals negative 5a minus c to the third. And then lastly, to isolate that x, we're going to go ahead and divide both sides by m minus z so that we can cancel it on the left and just finally be left with x equals negative 5a minus c to the third over m minus z. That's it. That's all we're going to do for today.